I will talk a bit about our relevance engine, or how we dub it these days, detecting engaging language. So I start off with a little note. I got a speaker brochure for data natives. People told me to be engaging. So I try to hold myself accountable for this and use these 15 minutes to just cram in a lot of information. Let's speak later if you want to get into details. I think that makes a lot of sense. So me, blurbs, usually put them on. So here's a question. How many conversations have you not started with a question? That's what you usually do. And I think that's the power that we use at Opinary. So what do? We ask people their opinion on any given topic. That could be political, culturally, sports, variety, in the publisher content, right? Here you can see one of our tools, our publisher partner Spiegel Online, a topic which is highly debated between German population, which means, I don't even know the English translation. Do we want to change, how do you call it when you turn the clock? I don't know. Germans are very opinionated about this. As you can see, if you speak German, they don't want to change the clock to summertime, right? And this is our tool. Basically, we run this tool on a couple of publisher platforms. Easy visualization, easy quick look, and we show the distribution of what people think there. So these are a couple of our partners. So some of you might have seen us. It's actually nice to experience when people come to the stand that they've seen us and a couple of German publishers there. So what does it mean on a daily basis? So maybe let's talk about our data set, and that will probably lead us to how we can reuse this. This is a day of voting in Opinary backend systems, right? I just checked the German traffic, and what is going on? It's nice. I love to see patterns in time series. People wake up and they start to be opinionated. Then people start working, and they're less opinionated, but you see, like, they're at the computer, and instead of playing solitaire, they're reading the news. And then they have lunch. More opinions. Then back a drop, you're tired, no opinions anymore, but then comes tea time and you commute home. What is very funny is that you can see that pattern here throughout, right? It looks the same, right? Behavior is the same throughout the days. So I keep saying I love time series data to my colleagues, and that is a very easy example of that. So that means, but also you can see these are requests per opinions per second. We are a pretty high traffic site, so there is a lot of more traffic going on in the system, but there's a lot. We collect millions of those. That means we have articles that are in publisher sites. We have users, and we have our beautiful polls. And now, how do we do this? And that's probably the thing I want to go into now, not probably, I want to go into now, is that we have to distribute this somehow. What does it mean, distribution? Of course, publishers can use our tools and put it manually into a poll and say, like, hey, I wrote this piece, I wrote this opinion piece, and here is the poll that fits into it. Let's ask the audience, what do they think here? But you all want to scale this out, right? And so what we did is we built a system that automatically injects the polls into the publisher content. And what's the problem that we're trying to solve here is we want to show the most relevant poll to the current article. That means we have to understand what the article is about, and we try to optimize for a vote. I mean, we can argue about this, but I will just use a vote as a proxy for relevance. And that's what we've seen in the series before. So, okay, we have a user, we have an article, poll, how does it fit together? So here's an idea how we are currently think about this and what we're trying. So what if we could decode what makes language engaging? And I do something you shouldn't do when you talk publicly is like, I haven't decoded the genome, so spoiler alerts, no. Because otherwise I would be a liar, and I don't want to be a liar here on stage. But I can tell you how we think about this and what kind of technologies we use to start thinking about this. Because the simple topic of optimizing for engagement, or optimizing for a vote here, you kind of know this in advertising technology and other things. And how do you make sure that you don't fall into the same traps, right? That you reinforce things constantly, that you reinforce your filter bubbles, that you reinforce anything which is just, yeah, I don't know, too eye-catching. By the way, this is, I found this online, this is the New York Times title page when the First World War started. Just as a side note. And the New York Times still looks similar. So here, a couple of approaches to think about this, to go down this. What you usually start off with when you have that kind of data sets is you will use the classic tabular data. And not sure what you guys are working in or if you're what fields or domain you're in, but that's the classic stuff you have, right? You start off with what do you know about the time, what do you know about, in our case, about the poll ID, publisher ID, user IDs. You have geo-coordinates, you have operation system. Topics is actually not belonging here. But any kind of information you extract, right? And that's what I think you should always start simple. So I would say this is stage one in trying to predict if someone wants to vote on something, right? You start with the simple data. It's reasonable, it's reasonably structured, and you can do all the nice things on your computer, can run it on CPUs, easy enough. Well, actually, we have a lot of data that makes it harder, but this is reasonable. So what you would use, you have your structured tabular data. You would do classic predictions or run classic regression models. So start simple, always start with a linear regression. Then you can try other things like support vector machines, and then the fancy things of gradient boosted trees, or not fancy, but that's basically what everybody does these days. And or there is a concept called FFM, feature-aware factorization machines, which helps to combine features together. It's a dimensionality reduction technique, after all. So that's what I would say is step one, right? But this has nothing to do with opinions yet. This is classic, like looking at traffic. So let's pump it up a bit. Number two, step two. You want to engineer more features, right? You sit on all this stuff, and you want to find, okay, what is actually relevant? What is actually relevant about content? What is relevant about news? So you start doing the classic feature engineering game, or you add new things that you can extract here. So the basic use case entity detection, right? You want to know who is it about. That could be Angela Merkel, our chancellor, like our, if you're German. Like so, probably not our chancellor. But there's also the entity or the concept of the US presidency. That's also an entity. And you can run this over your data set. So I didn't say this, but it stands, we extract all the articles we see, and we start processing the text. So the next step is probably content classification. You will do classic supervised learning. You want to know, hey, does it fall into certain categories? Or you want to do some trend detection, time series, beautiful for trend detection, figuring out if something is on the front page or somewhere else. So throw this into your model. So we have step one, classic traffic data. Step two, some here engineered features. You can more or less use generic libraries for this. So that's, I would say, a lot of this is a solved problem. But still not good enough. And here comes the moonshot. And what we're currently trying is, but what is if we want more of the content into that? What is if we could derive purely from what is written in the article, and this would be assumed given the article would be the strongest feature here in our nice mumbo jumbo of features. What can we do with this? So we started to go deeper. I think that's what everybody tells you these days. But the challenge here, I will just be briefly, so you want to go deeper, you want to use the whole article and throw it into the model, right? So we have tabular data, some engineered features we extracted, and now we go deeper and we encode everything that is in there, right? So hope being here that there is a way to generalize better and to have something which is generally applicable. So you have to encode your sequences. I think if you're, again, I only have 15 minutes, so I have to be a bit brief here. You start with different chunks. You would start probably with TF-IDF models, a bag of word model. Not recommended for this because you completely get rid of all the sequence logic. And if you want to talk about language, and the kind of language we talk here about, probably the sequence is important. So you have to go into something like word vectors, and you can get word vectors and then have nice convolutions to have a sequence, or use those LSTMs that you probably have read about as well. So that is a way to encode a whole article and just throw it into your model here as well. So that's how you go deeper. Why this is interesting these days, just a couple of notes to point out, and why we started doing this, or why we started looking into this. We have more powerful language models these days, and if you're following the natural language processing research, transfer learning in natural language processing is really taking off, and it works, and a lot of it is accessible. You can try this yourself. The language model is accessible, pre-trained for you, and there are these nice papers, Sesame Street, Elmo and Bert, you know, because everything is cute and funny. But everything is open source, so that's the good thing here. I think the power is with less data, you can achieve higher accuracy. Again, all sounds beautiful or too beautiful to be true, but I can say from experience this works exceptionally well. So what you experience usually in the ImageNet, you can see this in natural language processing as well. So I think that makes it more feasible to train with less and get more out of it. Quick one idea is maybe how to combine and throw this together. I don't have a conclusive answer there, but what you want to do is, in the end, if you have all these different models, like you have your tabular data, the other data, and the deep model is how do you combine this? So you could usually, you can create an ensemble and do some bagging or boosting or whatever it is. What we currently look into is using the wide and deep approach. This is a joint training, so that you learn all the features together. Machines are still calculating, so I'm holding my breath, but that is also a very interesting approach for joint learning and combining deep features and wide features together. Yeah, 2 more minutes. A couple of notes about this. How to make this possible, or how to pull this off. I can just say, data engineers in the room, you have one of the most important jobs, because there is a lot of plumbing that is going on, that you can move these things back and forth, and you have to prepare a lot of the data. So get ready for data plumbing. Find some common approach how to use this. We use TensorFlow for training, and unsolved, but currently we do everything offline. So this is all offline training. This is not online training. And last word, this is one of my favorite XKCD comics. Yes, be aware what you train. Be aware that you just don't throw random stuff into your crazy linear algebra and then you get the real results. So there is a lot of tweaking you have to do to not lie with it. And the classic caveats: be able to monitor it. Ethics and natural language processing, it's a bit buzzy. I notice that it gets a lot of attention when you talk about this, but you can really condition your language models on the bias that exists in the language, in your publishers. So make sure that you have a way to shuffle your training data and that you know how to work with this. And last point, interpretability. It's hard. Right? It's hard. You have something, you see, it performs, it works wonderfully, but how do you know it's right? So, and I think that is, again, one of the responsibilities. We have a huge team, not a huge team, we have a team, don't use these words, large words, but we have a team also of journalists working with us so we can work together and review what we predict and what we look at, but it's important to look at what you get out of it. And that's on the second, done. Come say hi. We have a little stand downstairs in the third floor. And is there going to be an Ask Me Anything session? Okay. Thank you very much.